Welcome to maths class. In this video we are going to learn the trigonometric ratios for the complementary angle of theta. Before we start these questions, let us understand that topic. Trigonometric ratios for the complementary angle of theta. Complementary angle of theta. Let us say in any right triangle, one angle is theta. This is ABC right angle triangle. But here trigonometric ratios we know all that 6 ratios: sine, cos, tan, sec, cot, sec and cosec. Sec and cosec. These trigonometric ratios we all are knowing. We are knowing that if we work for this acute angle which is theta, then we know sine theta is equal to perpendicular by hypotenuse. Cos we are knowing base by hypotenuse, tan perpendicular by base, cot base by perpendicular, sec for this acute angle theta, sec theta hypotenuse by base, and cosec theta hypotenuse by perpendicular. But here we are going to learn this trigonometric ratio for complementary angle of theta. So let us know first, if angle, two acute angle, one angle is 90 degree in right angle triangle, another acute angle is theta. So what will be this another one more acute angle? How much will be? So when we ask children with theta and all, they won't be, sometimes some children are not able to answer, but just you think it is acute angle. If it is 20 degree, how many degree will be another angle? If it is 10 degree, what will be another angle? If this is 60 degree, what will be another angle? So to get this angle, you have to subtract this from 90, because one angle is already 90, these two sum will be 90. So alone if it is 80 degree, that will be 10 degree. So that 80 and 10 are complementary angle, they together make 90 degree. Their sum is 90 degree. That's why they are called complementary angles. So if this angle is theta, this angle will be 90 degree minus theta. Whatever may be the value of this acute angle, another acute angle will be 90 minus theta. So we are going to learn this trigonometric ratio for this acute angle, or maybe if this angle is theta, that will be another 90 minus theta. So if we talk about this, we have written this ratio. Let us go with the name. We will get here sine perpendicular AB by hypotenuse AC. Cos will be base BC for theta. For this angle we are writing this ratio, BC by AC. Tan will be perpendicular by base, AB by BC. And this another three you know reciprocal of, sine is reciprocal of cosec and all. Let us write down that also. Cot base BC by AB. Sec will be base by hypotenuse by base, AC by BC, and cosec hypotenuse by perpendicular, AC by AB. So these ratios are for this acute angle theta. Now we are going to learn these 6 ratios for complementary angle. What is that? Sine 90 degree minus theta. This is complementary angle. Ratio will remain same, cos 90 degree minus theta, tan 90 degree minus theta, again cot 90 degree minus theta, tan sec 90 degree minus theta. Trigonometric ratio for the complementary angle, cosec 90 degree minus theta. So for ratio will remain same. Ratio is what? Sine shows the ratio between perpendicular and hypotenuse. So that will remain same. But if this angle is 90 minus theta, for sine 90 minus theta, perpendicular will be BC, hypotenuse will be AC. Hypotenuse does not change, BC by AC. Cos base by hypotenuse. So for this angle, base will be AB. So AB by AC. Tan perpendicular by base, so BC by AB, and cot base by perpendicular, AB by BC. sec hypotenuse by base AC by AB. We are working for this complementary angle, remember, and cosec hypotenuse by perpendicular AC by BC. This is BC. Now let us see, these are 6 trigonometric ratio for the acute angle theta and the same trigonometric ratios for a complementary angle of theta. Which of them are equal? Let us see now these both. We find sine theta AB by AC and cos theta 90 minus theta AB by AC. We have worked in the same right triangle, but we are seeing sine theta is equal to cos 90 minus theta. You can see this AB by AC. That is what we are getting these ratios for complementary angle. We need to remember this, sine 90 degree minus theta is equal to cos theta. This all we have understood how they are equal, but finally we will know the result. This we need to know in order to solve these questions. That is why before starting that I have explained this to you. Then next we see cos theta BC by AC, and we find here sine 90 minus theta is BC by AC. That means cos theta is equal to sine 90 minus theta. Already sine theta, sine 90 minus theta is equal to cos theta, and cos 90 minus theta is equal to sine theta. Then next again we will see from here only, we see tan AB by BC, tan theta AB by BC. Again where is AB by BC? This, cot 90 minus theta. That means cot 90 minus theta is equal to tan theta. So, cot 90 minus theta is equal to tan theta. Then next one, if we see, cot theta is BC by AB and tan 90 minus theta is BC by AB. That means tan 90 minus theta and cot theta are equal. So, tan 90 degree minus theta is equal to cot theta. This same way we see sec theta AC by BC, cosec theta is AC, cosec 90 minus theta is AC by BC, and cosec 90 minus theta is equal to sec theta. Cosec 90 degree minus theta is equal to sec theta, and then we will find cosec theta is AC by AB and sec 90 minus theta is AC by AB. That means sec 90 minus theta is equal to cosec theta. So, these are sec 90 minus theta is equal to cosec theta. So, these are 6 trigonometric ratios for the complementary angle of theta. For complementary angles of theta, we need to remember it. Now, this we are going to solve in this exercise 8.3. Let us start the exercise. The question number B2 is, so that 1048 into 1023 degree into 1042 degree into 1067 degree is equal to 1. So, two parts are there in this question, LHS and RHS is equal to 1 we have to solve. So, we are starting the work from LHS. It is 1048. We know tan 90 minus theta is equal to cot theta. So, we will change one 10, we will get cot. Next again 10 we have 23, we will use tan 90 minus theta, we will get cot. So, let us change that to 10. How we will change? Into complementary angle of theta. So, at this step little we need to think, what shall we subtract here from 90 so that we will get 48? We will not write here 48. 90, if we write here 90 minus 48, then it will be how much? See, 10 minus 8 will be 2 and 7 minus 8 minus 4 will be 4. It will be 1042, but here is 1048. So, what shall we subtract from 10 to get 48? That will be 90 minus 48 you do, orally also you will be able to do, or 2, 4, 42. So that we will write here 90 minus 42 is equal to 48. Then next is what? Into 10, again 90 minus 23 we will do, and that we will write here. 90 minus 23 will be what? 70 what is that? 67. So 90 minus 67 will be 23. So these two we changed from 10 90 minus theta, we will get cot theta. So another two we will not change. 1042 we will keep, and 1067 also we will keep it here. This all we will know only when we know that identities. We are changing 10, we will get cot, and cot and 10 again will be 1. That's why we are not changing another 10 and 1042 and 1067. So what we get here? 1090 minus theta, cot 90 minus theta, we get cot theta. Theta is 42. Again here 1090 minus theta, we get cot theta 67 into 1042 into 1067. And then we know the relationship of ratio, tan theta into cot theta equal to 1. Reciprocal ratio, any two reciprocal ratio we will multiply, we will get 1 only. So cot 42 and 1042 we will take into 1042. There is no sign between these terms, all are in multiplication. Again into cot 67 into 1067. Tan theta into cot theta, we get 1. Reciprocal ratio, angles are also same only. Cot theta into tan theta 1. Finally we get 1 into 1, that is RHS. So simple thing, but we need to know these trigonometric identities for trigonometric ratios for complementary angle theta. Let's see question number 2 also. This is here again to prove only. So we start our work from LHS. Then we see cos 30, cos 52, sine 38, sine 52. So we will change cos into complementary angle, we will get sine. We will again change another cos, we will get sine, and another side both sine are there. So any one side, if this both we will change, or if this both we don't change, another two we will change. So it is up to us. So let us start, we will change from the starting. 90 minus what? 38. 90 minus 52 will be 38. Like this, cos 90 minus what we will get? 52. 38. 90 minus 38 is 52. Then this both we are changing. After minus, this both we will not change. We will get here sine 52 as it is. And then remind yourself, you have changed into complementary angle ratio. After that, cos 90 minus theta is equal to sine theta. Theta is 52. Here also cos 90 minus theta, sine theta, that also sine 38 minus sine 38 into sine 52. What we see at this step? Sine 52 into sine 38, sine 38 into sine 52. That means these whole are cancelled. One is negative, another one is positive. We have got 0 RHS we have proved. So hope you have understood how the complementary angles ratios are and how we use it in solution. See you in next video.